As we continue with polynomial equations, in the next set of videos, I'll be focusing more on solving different types of polynomial equations. I mean, we've done that here and there in previous videos, but this one is like we are actually focusing on solving in particular. In the past, we've talked about factorization and types of roots and things like that. But here we want to talk about solving, and in this particular video, our focus is on solving linear and quadratic equations. So I said already that you can have polynomials in different forms according to degrees, right? According to the power of the highest power of the variable x in most of the cases. If the power is 1, you say you have linear. If the power is 2, it's quadratic. If the power is 3, it's cubic. If the power is 4, it's quartic. If the power is 5, it's quintic, and so on and so forth, right? So in this lesson, we study solving linear equations of the form ax plus b equals 0. So then we solve quadratic equations using factoring, which we've considered in the past, completing the square, quadratic formula, the discriminant. We'll talk about the discriminant d equals b squared minus 4ac and the nature of roots. We've considered that also in previous videos. Going straight to solving linear equations, ax plus b equals 0, that form. So we know, just like I said already, a linear equation in one variable is an equation that can be written in the form ax plus b equals 0, where a and b are real numbers and a is not equal to 0. Of course, if a is equal to 0, then this becomes a constant. You just have b that is 0. So its graph in the xy plane is a straight line. Of course, that's why we say it's a linear equation, right? So its graph is a straight line. So the solution is a single value of x. Because it is of degree 1, then we expect just one solution. Just like I said previously, for a linear equation, you expect one result, one solution, one root, because the highest power of x is 1. When the highest power of x is 2 for a quadratic equation, you expect two solutions. For cubic, you expect 3, quartic, you expect 4, and for quintic, that's 5, and all that. So now solving ax plus b equals 0 in particular, so starting from ax plus b equals 0, I mean, this is straightforward. The first thing you want to do is subtract b from both sides. So you have ax plus b equals 0. So ax plus b minus b equals 0 minus b. So b cancels out. So you have ax equals minus b. And since what you're looking for is x, so when you solve a polynomial, right, you're looking for the value, the possible value or the possible value of values of x. For linear, you're expecting one value. So we say the possible value of x. Now you have ax equals minus b. So if you divide both sides by a, of course, with a not equal to 0, because if a is 0 in the first place, it is not even linear, right? It is just a constant polynomial, so to speak. But with a not 0, we can then say we divide both sides by a, so we have ax over a equals minus b over a. So a cancels out on the left hand side, and then we have x equals minus b over a. So the solution of ax plus b equals 0 is x equals minus b over a simply. So just identify b and a and just put minus in front, and that's the result. So let's talk about a general linear equation. Like, in the first case now you have ax plus b equals 0. But what if you talk about a general situation where you have ax plus b equals c? So it's equal to a particular number, not 0 per se. So in this case now, so it means that you have ax plus b equals c, and if you consider ax plus b equals c, then if a is not 0, of course, ax equals c minus b, and then you can divide through by a, and that means you have x equals c minus b over a. So if a is equal to 0, the equation becomes b equals c, of course. So if a is 0, yeah, if a is 0, then we just have b equals c. All right. So if b is equal to c, it means you have infinitely many solutions, right? So yeah, and then the identity will be 0x plus 3 equals 3. And if b is not equal to c, in that case, you have no solution. All right. And then there'll be a contradiction. So that's if you say b equals c now, that's the condition for all this now. So 0x plus 3 will be 5. And that will be a contradiction. So there's no solution in that regard. So let's look at some very simple examples. So 3x plus 5 equals 0. So of course, subtract 5 from both sides. So you have 3x equals minus 5. Divide both sides by 3. So you have x equals minus 5 over 3. It's just straight to the point. Minus 4x plus 7 equals 0. That's minus 4x equals minus 7. Divide both sides by minus 4. So you have x equals minus 7 over minus 4. That's equal to 7 over 4. Or if you want to go by minus b over a. So a is minus 4 B is 7. So you have minus 4 over 7. So minus cancels minus. I mean minus 7 over 4 rather. So minus cancels minus. So you have 7 over 4 at the end of the day. So you have half x minus 3. So to get this done, you multiply both sides by 3. Or you can transfer 3 first of all. Subtract 3 from both. Add 3 to both sides because it's negative here. So you have to add 3 to both sides to get it out of here. So you have half x equals 3. And then you want x, right? The only way to get rid of x is, I mean, to have x standing alone is to multiply through by 2. So 2 times 1 over 2 times x is x here. Then 3 times 2 is 6. So, and that works. Half times 6 is 3. 3 minus 3 gives you 0. So you can check like that. So, I mean, linear equations are very straight to the point. So you don't have to sweat a lot to get results. So let's move on to quadratic equations. So for basic ideas, I mean, we've dealt with this a couple of times in other contexts, not in the context of solving per se, though we ended up solving in some situations. But here we are actually focused on solving. So a quadratic equation in one variable is an equation that can be written as ax squared plus bx plus c equals 0, where a comma b comma c are real numbers and a is not equal to 0. So the graph is a parabola, of course, and we've seen a lot of that. There can be 0, 1, or 2 real solutions. So you can have no solution, one solution, or 2 real solutions for a quadratic equation. So talking about the standard form now, we have this. Any quadratic equation can be rearranged into ax squared plus bx plus c equals 0 by moving all terms to one side, right? So you have ax squared plus bx plus c equals 0. So example, if you have x squared plus 5x equals 6, that implies you have x squared plus 5x minus 6. That's if you bring 6 back here, then you have a standard quadratic equation in which follows this idea. So here now you can say that a is 1 because the coefficient of x squared here is 1. So a is 1, b is 5, and c is minus 6. So talking about uh, method one for solving quadratics. So you can solve quadratic equations by factoring, which we saw in previous videos. Suppose we can write that ax squared plus bx plus c equals px plus q rx plus s. So using the zero product property, zero product means that if the product of two things, of two parts is equal to, of two factors, so to speak, is equal to 0, then it means that of the factors either or both of the factors is 0. So px plus q rx plus s equals 0 implies that px plus q is 0 or rx plus s is 0. So at least one of them must be 0. So that's the zero product property. Then we can then solve these resulting linear equations. So that's if we are looking for ax squared plus bx plus c equals 0, and then we can then factor ax squared plus b plus x into plus bx plus x as px plus q rx plus s, and then we equate to 0, then we can then equate each part to 0 and we solve. So let's look at a simple case where the coefficient is simply 1. So consider x squared plus bx plus c equals 0. That means a is 1. So we look for two numbers, m and n, such that m plus n is b. We've done this a couple of times, so I may not even take too much time on this. So mn is equal to c. Then we say x squared plus bx plus c is the same thing as x plus m. X plus n equals 0. When we then solve x plus m equals 0 and x plus n equals 0 to get our values of x. So a simple example we've been using all the while is this. So you want to solve that for x squared plus 5x plus 6 equals 0. We need numbers whose sum is 5 and the product is 6. So the two numbers whose sum is 5 and product is 6 they are simply 2 and 3, right? 2 plus 3 is 5 and 2 times 3 is 6. So you have x squared plus 5x plus 6 equals x, we are looking for x plus m and x plus n. So you have x plus 2, x plus 3 equals 0. So if you now use the zero product property, so x plus 2 is 0, which implies that x is equal to minus 2, and x plus 3 is 0, which implies that x is equal to minus 3. So the solutions are x equals minus 2 and x equals minus 3. Those are the solutions. Then we also have a case where a is not equal to 1. And then in that case, we use the AC method. That's the AC is referring to the coefficient of x squared, that's the leading coefficient, and the constant c here. So because a is not 1 this time around, we have to compute AC. So AC method, we factor by grouping. So compute a, which is AC. So find two numbers that multiply to a, that multiply to the AC basically, and add up to b. Instead of just this, here it was just C we're focused on, just the 6. But now X has a coefficient, so we have to pay attention to that. Okay. So then we rewrite the middle term using these two numbers. Then we factor by grouping. This works well when A, B, and C are integers and the quadratic factors nicely. So let's look at this example right here. Okay. So example 2, now you have 2x squared plus 7x plus 3 equals 0. So you identify A, B, and C. A is 2, B is 7, and C is 3. All right. So we have to compute AC. That's 2 times 3 is 6. So instead of just working with this 3, now you have to multiply it by 2. So we now need two numbers that multiply to give us this 6, not 3 anymore. But when we add, we still get 7 in the middle. And those numbers, of course, we have to look at the factors of 6, 2 and 3, 1 and 6. No, okay, 2 and 3 will not give us 7, but 1 and 6 will give us that. All right. Since it plus 7 is what we are looking for, so 1 and 6 will fit the bill. So we can write the middle term. That's 2x squared plus 7x plus 3. And that will be equal to 2x squared plus x plus 6x plus 3, because 7x is the same thing as x plus 6x, right? So if you factor by grouping, we have 2x squared plus x. That's put these two together, plus 6x plus 3. So we can then factorize x out of this. So we have x into 2x plus 1 plus 3 is common to 6x and 3. We have 3 into 2x plus 1. So we can then have 2x plus 1 is common to both terms. So we have 2x plus 1 out, and then that will be going, we multiply by x plus 3. So because we are solving, we now solve and say 2x plus 1 into x plus 3 equals 0. So 2x plus 1 is 0. And if you divide through that, so first of all, you transfer 1 to the other side, subtract 1 from both sides. So you have 2x equals minus 1. Then secondly, you divide both sides by 2. So x now is minus half. And for here, just subtract 3 from both sides. So you have x equals minus 3. So the solutions, the solutions are x equals minus half and x is minus 3 easily. Now, when is factoring convenient? So factoring is usually the best choice when coefficients are small integers. So if you have small integers, factoring is excellent. The quadratic appears to factor neatly. So if you can factor neatly, like all the cases we've seen, factoring works. You can quickly find two numbers that satisfy the sum and product conditions, right? So if factoring seems difficult or messy, you can switch to the quadratic formula, which we go for next. And to get the quadratic formula, we get the quadratic formula via the completing the square method. In a previous video, I went through the pain of deriving the completing the square method, but here again, we'll talk about it again, right? So completing the square, the idea is we transform the quadratic into a perfect square form, which is like a into x minus h squared plus k equals 0, which is easier to solve and also gives the vertex form of the quadratic function. So for simplicity, we can start with the case a equals 1. So like you have x squared plus bx plus c equals 0. So we now go for steps. Steps for x squared plus bx plus c equals 0, completing the square. So you start with x squared plus bx plus c equals 0. Then you move the constant term, that's plus c. You move it to the other side. You know, in the standard form, the c has to be here. But to complete the square, now you have to move it away so that you can deal with the things with the variables. So you now have x squared plus bx equals minus c. Then the next thing you want to do is to take half of b and square it. That's whatever the coefficient of x is, take it. That's b divided by 2. So take the coefficient of x divided by 2 and square it. So when you square that, adding this square to both sides. So if you add this to both sides now, you would have squared the left-hand side. So you have x squared plus bx plus b over 2 squared, and that is equal to minus c plus b over 2 squared. By adding it to both sides, you have actually balanced the equation, right? And by doing that, you have basically made the left-hand side into a perfect square. So the left side is not a perfect square, which can be written as x plus that half you got, so x plus b over 2 squared. Because if you expand this now, you basically get this back because x, of course, we have that fast method. So x squared plus 2 times x times b over 2. So 2 cancels it. So we have basically bx. Then plus b over 2 squared. We have this. So we are still good. So that's minus c plus b over 2 all squared. So we can then take the square root of both sides. So if you take the square root of both sides, now take the square root of this side, the square goes, you have x plus b over 2. If you take the square root of this side, then you have plus or minus because of the square root, that's to be plus or minus. So you have minus c plus b over 2 squared. All right. So we can then solve for x. So to solve for x, now you transfer this b over 2 to the other side. So you have x equals minus b over 2 plus or minus square root of minus c plus b over 2 squared. And then we can still tidy this up further. We can tidy it up further, or we can use it like that. So let's use it like that, for instance. So example 3, you want to solve for x squared plus 4x minus 5 equals 0. You want to solve for x. by completing the square. So what you first of all do is move the constant. That's 5 minus 5 becomes 5 on the right hand side. Then you can now take, so the coefficient of x here is 4. So take half of that 4, that is 2. Okay, and then square it. So this is like, this 4 now is now like 2 squared, and that is equal to 5 plus 2 squared again. So that's x squared plus 4x plus 4 equals 5 plus 4. So left side is a perfect square. That's x plus 2 squared. So by adding this square, now this is perfect square. So you have x plus 2 squared equals 5 plus 4, 9. So if you take the square root now, so this square will be gone. So you have x plus 2 equals plus or minus 3. All right. Then you can then solve everything completely because you're looking for x. So you have x is equal to 2 plus 3, or x is equal to 2 minus 3. So you can say x plus 2 is positive 3, and that will simply be x equals 3 minus 2, which is 1. And then x plus 2 is minus 3 also. So you can transfer plus 2, it becomes minus. So x is now minus 3 minus 2, that's minus 5. So the solutions are x equals 1 and x equals minus 5, like that. But then we can still do the general form. um Okay, the general case now is where you have ax squared plus bx plus c equals 0. So you start with ax squared plus bx plus c equals 0, where a is not equal to 0. Then you divide every term by a, that's x squared plus b over ax plus c over a equals 0. So then you move the constant. So the constant now is c over a. So you have minus c over a here. So x squared plus b over ax equals minus c over a. So take half of b over a and square it. So you have b, so this b over a now, take half of it, that's b over 2a. Right? That's half times b over a. That's b over 2a. And then if you square it, you get b squared over 4a squared. Then you can add this to both sides and complete the square. So if you add this to this left-hand side, it completes that square, which is going to be x plus this b over 2a, first of all squared, right? And then you also add the same thing to the other side. So this process leads to the quadratic formula. And you see, we've not completed this process here. By the time we add, now we get the quadratic formula. So method 3 now is now the quadratic formula. So you can actually use the completing the square directly to solve a problem. And then, but if you continue simplifying the quadratic formula, this completing the square, you end up with the quadratic formula. So by the time you add b over 2a, that's b squared over 4a squared to both sides, you end up getting this result right here. So for the quadratic equation, ax squared plus bx plus c equals 0, a is not equal to 0. So the solutions are given by the quadratic formula x equals minus b plus or minus square root of b squared minus 4ac over 2a. This formula works for every quadratic equation as long as a is not equal to 0. Okay, so if you want to derive this by completing the square now, so we have the whole process leading up to that. Okay, so let's see. Okay, let me go full. So you start, so to derive that by completing the square, now you start with ax squared plus bx plus c equals 0. It's the same thing we've been doing before. So you can then divide by a, that's ax squared over a cancels out. So we have x squared, b over ax plus c over a equals 0. Then move the constant. So you have x squared plus b over ax equals minus c over a. Then add, to complete the square, now take half of b over a, that's b over 2a, then square it. So you have b over 2a squared. So b over 2a squared is b squared over 4a squared, like we saw just here, like in this case now. Okay. So if you add that to both sides, okay, let me go step by step. So if you add b over 2a squared to both sides, you have x squared plus b over ax plus b squared over 4a squared equals minus ca plus b squared over 4a squared. Okay, so the left side is the perfect square now. So you have x plus b over 2a. So usually the left side will be x plus b over 2a, and then you can square it, and that will be equal to, if you simplify this now, LCM is 4a squared. So a in 4a squared is 4a. So 4a times c, that's minus 4ac because of this minus right here. Then 4a squared and 4a squared is 1. 1 times b, that's b squared. So this has been rearranged here. So x plus b over 2a all squared is b squared minus 4ac over 4a squared. Then we go for the next step where we take square roots. So square root of this, the square is gone. So we have x plus b over 2 equals plus or minus square root of b squared minus 4ac all over 4a squared. So square root of b squared minus 4ac is what you have at the top. Square root of 4a squared is square root of 4 to square root of a squared. That's 2a. Okay, and then we can then tidy everything up. So we can solve for x by transferring minus b over 2a to the other side. So we have minus b over 2a plus or minus square root of b squared minus 4ac over 2a. The LCM is 2a. So 2a into a is 1. 1 times minus b, that's minus b plus or minus 2a into a 1. 1 times square root of b squared minus 4ac. You have square root of b squared minus 4ac. So we can then talk about example 4. So in example 4, we can solve for 3x squared minus 2x minus 8 equals 0. So here, just identify a is 3, b is minus 2, c is minus 8 easily. Then compute the discriminant. The discriminant is b squared minus 4ac. I think we talked about discriminant in a previous video also, or a couple of times even. So you have b squared, that's minus 2 squared, minus 4, that's 4 times a, 3 times minus 8. So that's minus 2 squared is 4. Then minus and minus is plus. 4 times 3 is 12. 12 times 8 is 96. 4 times 4 plus 96 is 100. So if you apply the formula, you have x equals minus b plus or minus square root of d over 2a. So minus and minus is plus. So you have 2 here. Square root of 100, that's 10 all over 6. So you can then have, this 2a is 2 times 3 6. So x can then be 2 plus 10 over 6. That's 12 over 6, which is 2. Then x can be 2 minus 10 over 6. That's minus 8 over 6, which is minus 4 over 3. So in that case, the solutions are x equals 2 and x equals minus 4 over 3. So talking a little bit more about discriminants, we've talked about it before, so I won't take too much time discussing it because I think I dealt with it in depth in a previous video. So for the quadratic equation, ax squared plus bx plus c is 0. So the discriminant is the quantity d equals b squared minus 4ac. That's this thing you find under the square roots. So that determines how the solution looks like, right? So the discriminant helps us determine the nature of roots or solutions or zeros, like we can say, without solving the equation completely. So classification by d equals b squared minus 4ac, we can have this. So if d is equal to 0, that is, d is positive, so you're going to have two distinct real roots. So if d is a perfect square, like 1, 4, 9, 16, the roots will be rational, you will not have maybe a surd in that case. So because you get this a whole number from that discriminant part. So if d is not a perfect square, the roots are irrational, involving square roots, maybe like 1 plus root 2, 1 plus root 3, and things like that. Then if d is equal to 0, of course, that root part will be gone. So in this case, you have one real repeated root, which is, in that case, you can have a double root, or what we called multiplicity in a previous video. So the parabola touches the x-axis at exactly 1 point in this case. So that just like you have maybe you're solving for x squared plus 4x plus 4. All right, so you're going to have double roots in that case. So for d less than 0, in that case now, that part under square root is negative. That is going to lead you to complex numbers, imaginary value. So no real roots in this case. So you're going to have two complex conjugate roots. The parabola does not intersect or touch the x-axis at all because you're talking about imaginary roots in that situation. Okay, so example 5 now to deal with this idea. So you have x squared plus 5x plus 6 equals 0. So here a is 1, b is minus 5, c is 6. So the discriminant is b squared minus 4ac. So that's 25 minus 24, which is 1. 1 is greater than 0. So this 1 now is greater than 0. So it's positive and it's not a perfect, oh, it's a perfect square, by the way. So you're going to have two distinct real roots because this is a perfect square. So the root will be rational. If you had like, maybe if you had like 2 here, it means you're going to have square root of 2, and that's going to be irrational, but you still have two distinct roots. So you have x squared plus 4x plus 4 equals 0. So here a is 1, b is 4, c is 4. So b squared minus 4ac, right, for the discriminant will be 16 minus 16, which is 0. So here you're going to have one real repeated root. In fact, x is just minus 2 doubled. So minus 2 with multiplicity 2. Then you have x squared plus x plus 1 equals 0. Here a is 1, b is 1, and c is also 1. All right. So d now is b squared, that's 1 squared minus 4 times 1 times 1. That's 1 minus 4, that's minus 3, which is less than 0. So in this case, you have no real roots. There are two complex conjugate roots. So you have the real and imaginary parts are the same, except that one is positive and one is minus. That is why they are said to be complex conjugates. I think that was what we talked about in the last video, talking about conjugate pairs. Okay, so the question now is how do you choose a method to solve a quadratic? So given a quadratic equation ax squared plus bx plus c equals 0, you can choose a method as follows. Check for easy factoring. Can you easily factorize? Are a, b, and c small integers? So that can help to factor. Can you quickly find numbers that satisfy the sum and product pattern? That is, you need two numbers that will that will give you a product of ac, or that will and that will at the same time add up to b. All right. If yes, you can use factoring, which is usually the fastest. If factoring is difficult or not obvious, you can use the quadratic formula. For instance, if you're dealing with symbolic expressions, like you just want to do it the way it is. So in that case, the quadratic formula is really helpful. So you can have x is equals minus b plus or minus square root of b squared minus 4ac over 2a, which we saw already how to derive. So this method works for every quadratic, no matter what it is like. And then using use completing the square when you want the quadratic in vertex from A into x minus h all squared plus k. Then you're preparing for graphing optimization, or you want to understand the derivation of the quadratic formula. So you should use the completing the square in that case. So here now we have solve for x, solve for x for linear equation. Now solve each equation. Well, I think I'll take what looks seemingly the hardest is 2 over 3x minus 4 equals 0. 2 over 3x minus 4. So you have 2 over 3x minus 4 equals 0. First of all, add 4 to both sides. So you have 2 over 3x minus 4 plus 4 equals 4. I mean, you add 4 to this. So, equals 0 on the right-hand side, right? 0 plus 4. Okay, so this cancels out. So we have 2 over 3x equals 4. Next thing, you know you're looking for x. So multiply both sides by 3. So you have 3 times 2 over 3x equals 3 times 4. So 3 cancels 3. So you have 2x on the left-hand side equals 3 times 4 is 12. Now you can divide both sides by 2. So you have 2x over 2 equals 12 over 2. So this cancels out. So x now is equal to 6. So x is 6. You can also check, if you want to check if what you have done is correct. So the way to check is go back to the beginning. You have 2 over 3x minus 4 equals 0. So if you put you have 2 over 3x minus 4 equals 0. So you can just put the 6 now. So you have 2 over 3 times 6 minus 4. So 3 here is 1, 3 here is 2. 2 times 2 is 4, 4 minus 4 is 0. So this gives you the right answer. So we are good to go on that note. Okay, so here, this one says solve by factoring. So to solve by factoring, let me take what looks like the most difficult. That is number 8. That's why I think it's most difficult. 3x squared minus x minus 2. We want to solve by factoring. 3x squared minus x minus 2. Okay, so you have 3x squared minus x minus 2 equals 0. We want to solve that. A is 3. That's the coefficient here. B is minus 1. That's the coefficient of x. And C is minus 2. That's the constant right here. Okay, so we need to compute AC. AC is 3 times minus 2. That is minus 6. So we pay attention to this. Okay, so and then we need two numbers. So our focus now will be on B equals minus 1 and AC is minus 6. So we need two numbers like say m plus n, that when we add, we get minus 1. And when we multiply, we get minus 6. And they are usually they are usually factors of minus 6. Okay, so the possible values, factors of minus 6, we have 2, 3, 6, 1, or minus 2 and 3. Okay, this is minus, right? So one has to be positive and one has to be negative. So we can have minus 1, 6. We can have 6 minus 1. We can have 2 minus 3. We can have 3 minus 2. And I think that's about all possibilities. But when we add them together, we should get minus 1. So if we add this, it gives us 5. If we add this, it gives us oh, okay. I've messed up something here. So minus 1, 6 and 1 minus 6. Okay. So 1 minus 6 will give us minus 5. 2 minus 3 is minus 1. 3 minus 2 is 1. So 2 and minus 3 is what we need. All right. 2 and minus 3. So we can then go and say 3x squared minus x minus 2 is equal to 3x squared. So this minus x now is like plus 2x minus 3x minus 2. So this 2x plus 3 minus 3x is minus x. Say easily. So we can then factorize. So we have 3x squared plus 2x minus 3x squared minus 2. So we can group. And if we want to group this other side too, so because minus is outside, this is sign inside changes to plus. So we can factorize. X is common, so we have x into 3x plus 2. Here, nothing is common. It's technically, so if nothing is common, then 1 is common. That's 1 into 3x plus 2, like that. So in that case, we can then say 3x plus 2 into x minus 1. This x and minus 1 here. So 3x squared minus x minus 2 equals 0 implies that we have 3x plus 2 into x minus 1 equals 0. So that means that using the zero product formula, so zero product property, so 3x plus 2 equals 0, or x minus 1 equals 0. So that means 3x is equal to minus 2 if you subtract 2 from both sides. or x is equal to 1. So this one is settled. And then we can divide both sides here by 3. So we have x is equal to minus 2 over 3. Okay. So, so x is equal to minus 2 over 3, or x is equal to 1. That's the solution we're looking for in that second set of equations. Then we come here, it says solve by completing the square. So I'll go for, anyone is fine, x squared minus 4x plus 1, x squared minus 4x plus 1, completing the square. Okay, x squared minus 4x plus 1. So, so talking about x squared minus 4x plus 1 by completing the square, by completing the square. Okay, so we have this is 0, right? We want to solve that. So we have x squared minus 4x. Transfer the constant to the other side. That's x squared minus 4x equals minus 1. Then we complete the square on the left-hand side. And the way to complete the square is we have x squared minus 4x plus this minus 4 now. We have minus 4 divided by 2, and we square it. And then we add the same to the other side, minus 1 plus minus 4 over 2 squared. Okay? So this minus 4 now divided by 2 and square it. That's the way to make this one square. So we have x squared minus 4x plus minus 4 over 2 is minus 2 squared. This minus 2 is really important. Okay? That's minus 2 squared. And that is equal to minus 1 plus minus 2 squared. But of course, square is going to cancel the minus. So we have squared minus 4x plus 4 is equal to minus 1 plus 4. Okay, but so this whole thing now is a perfect square, but then it's like x, then this minus 2, this is where it now becomes important. X minus 2 all squared, that's what it means now. So this x and minus 2 all squared. So because if you expand this now, you get this. So that's x squared times minus 2 times x times 2, that's minus 4x. Then minus 2 squared, that's 4. So minus 1 plus 4 is simply 3, you know. So the next thing, you take square root. So square root of x minus 2 squared is equal to square root of 3, right? So this cancels this. Of course, this is plus or minus here. So you have x minus 2 equals plus or minus root 3, right? So that you can then say x is equal to 2 plus or minus root 3. And then that means that x is equal to either 2 plus root 3 or x is equal to 2 minus root 3. Of course, you can go further and take, root 3 is 1 plus 1.732, or you can also leave them this way. Okay, that's by completing the square. So because this 3 now is not a perfect square, that's why we have irrational values, distinct roots, which are irrational. Okay, that's about completing the square. So here it says discriminant and quadratic. For each equation, compute the discriminant D, state the nature of the root, whether it is 2 real or 1 real or complex. Solve using the quadratic formula then. So let me take what I might think is the hardest. That's number 13, x squared minus 9x plus 20. Okay, x squared minus 9x plus 20. So x squared minus 9x plus 20. Is that correct? Hope I didn't get that wrong. X squared minus 9x plus 20. Great. Okay. X squared minus 9x plus 20. So in this case now, so we are using quadratic formula equals 0, by the way. That equals 0. Equals 0. So we know A is 1, that's the coefficient of x squared. B is minus 9, and C is 20. Okay. So the discriminant is D equals B squared minus 4AC. Okay, that means you have D equals, B is minus 9. So we have minus 9 squared minus 4 into 1, and C is 20, I believe. Yeah, I think that's it. So we have D is equal to 9 squared is 81. So 81 minus 4 times 20 is 80. So D is equal to 1, interestingly. Okay, so D is equal to 1, right? So we can say since D is equal to 1, which is greater than 0, okay, we have two distinct two distinct roots. Okay, we can also add that since D equals 1 is a perfect square, Okay. We have we have two distinct two distinct rational roots. Two distinct rational roots. So we won't have a sort like what we had in the previous problem we solved using completing the square. So we have completed the discriminant, we've stated the nature. It's going to be two real and rational. Solved using the quadratic formula. So we can then go ahead solving using the quadratic formula. Okay. So using the quadratic formula, using the quadratic formula, okay. So we can then have x is equal to minus b plus or minus square root of b squared minus 4ac all over 2a. Okay, again, to remind ourselves, we know a is 1, I think, b is minus 9, and c is 20. If that's, I think that's what we have. I think so, yeah, that's cool. So now we already know we're going to have two distinct rational roots. So in this case now, we have x equals minus b is minus 9, so that's minus 9. Don't forget, don't let the minus confuse you. So b is minus 9, so the minus, they don't lose it, okay, because that can scatter everything. So that's square root of b squared, that's minus 9 squared, minus b squared, now that's minus 9. Okay, that's b squared already. B squared minus 4 times 1 times 20 all over 2 times 8, that's 2 times 1. Okay, so we have x is equal to 9 plus or minus square root of minus 9 squared, that's 81, minus 4 times 1 times 20, that's 80, all over 2. Okay, so x now is equal to 9 plus or minus square root of 81 minus 80, that's 1, all over 2. Okay, so we have x now is equal to 9 plus or minus square root of 1 is 1, all over 2. Now we can have x is equal to 9 plus 1 over 2, or x is equal to 9 minus 1 all over 2. So x is equal to 10 over 2, or x is equal to 8 over 2. So that means that x is equal to 5, or x is equal to 4. And that's all we have. Okay, so that goes. So how do you check if the answer is correct? X is 5 or 4 or 5, right? So if you try this, so when x is 4, you have 4 squared minus 9 times 4 plus 20. So 4 squared is 16 minus 36 plus 20. So 16 plus 20 is 36. 36 minus 36 is 0. Okay? So you can see 4 is a good solution, is correct. What about checking for 5? So to check for 5, okay, just do the same thing. So you have 5 squared minus 9 times 5 plus 20. That's 25 minus 45 plus 20. So 25 plus 20 is 45. 45 minus 45, that's 0. So it means 4 and 5 are actually good answers. So on this note, we come to the end of this, I believe. I've taken one question from each possible area we've considered. Thank you so much. So you want to try your hands on the rest of these questions. Let me know how helpful this is for you. And if there's something else you'd like me to try out, feel very free to let me know. If you have subscribed already, I thank you very much for doing that. But if you have not subscribed, why not go ahead and subscribe right away and hit the notification bell so you can always get alerted each time a new video is released, right? Having done that, you can also become a member of the channel by clicking on join. So joining gives you a special privilege. At the highest level, we can have a hangout either physically if you're in the same geographical location at any point in time, or meet online to talk about anything that interests you on my channel, be it scholarships, mathematics, data analysis, data science, machine learning, whatever, scholarships, personal development, writing books. We can discuss any of these things that may catch your fancy. Thank you so much for listening. Don't forget to comment, like, and share so that more people can have access to this great content I have going on here. Till I come your way again, keep doing maths right. Bye.